right, question number 10. There are multiple ways to answer this question, but I'm specifically asking you to use equation 1-115, 115, we'll say. All right, so the question is, explain why metabolism could not occur if concentrations of metabolites were at equilibrium. Well, equation 115 is delta G equals delta G naught plus RT times the natural log of Q. All right, well, how does this equation explain what's asked for up there? All right, well, this delta G here, this is our actual delta G, and this Q here is the concentration of our reactants, whatever they may be, at those conditions. Well, if we're at equilibrium, right, Q can instead just be replaced with our equilibrium constant, because whatever those concentrations are that we would plug into Q are already at equilibrium. So it's going to be the equilibrium constant. All right, so now we end up with delta G is equal to delta G naught plus RT times the natural log of KEQ. All right, well, this might look a little better to you. Hopefully, if you're thinking about all the equations that we know from this chapter, hopefully you can see where we're going next. All right, well, what we're going to do is we're going to substitute something in here for delta G naught. We have another equation where we know that delta G naught is equal to negative RT times the natural log of KEQ. All right, so we're going to substitute that in here. And so we end up now with negative RT natural log of KEQ plus RT natural log of KEQ is equal to delta G. All right, well, this whole side here adds together to give us a big fat 0. All right, well, what does this tell us about the energy that's available to metabolism? Well, there is no energy available for metabolism. So if an organism is at equilibrium, there's no energy available to do any sort of metabolism. All right, that's what this equation shows us. Now, another way of answering the question without this particular using equation 115 would be that, at equilibrium, that means the rate of our forward reactions is the same as the rate of our reverse reaction. So, the rate that we're breaking down glucose, for instance, would be the same as the rate that we're making glucose. So if we're doing this particular type of metabolism, there's actually no net reactions happening. There's no you can't be taking in sugar and turning it into CO2 gas, because you should also be taking CO2 and turning it into sugar at the same rate. So because of this, an organism can't be at equilibrium and still be surviving. You can't make molecules, for instance, if you're at equilibrium, because you're going to be breaking them down at the exact same rate. So that's another way of answering it. The way with the equation, the consequence of being at equilibrium is that there is no free energy available for any reactions that you may want to carry out.